In this video, we will talk about the integer data type and the floating point data type. So earlier, we already talked about we will define variable in order to save some data. So sometimes what kind of variable we need to define is according to what kind of data you want to save. So if we want to save no decimal, only whole number, integer data type, so then you need to define your variable as integer data type. So the number you want to save, if they have a decimal, so then we need to define our variable as the floating point data type. So the first one, let's talk about integer data type. So actually, we only introduce you beginning is this one, right? We have the int items. So that's the integer data type. This int data type in the memory, they have 4 bytes. But we have even more. You see, we have short int. This one also is a data type. Since you can see they are a shorter integer, right? So the size is only 2 bytes. Or you have unsigned short int. So that means they only occupy 2 bytes, but they are what? Unsigned mean what? Unsigned mean no minus sign. On the other hand, you don't have plus sign. On the other hand, that means the number is only no sign, but no sign usually we consider they are positive, right? But we don't including the sign. Okay, so then we just see the first two. You have short int, unsigned short int, and int. According to the size, the memory size, so that's why you see your data range is different. Okay, so 2 bytes equal to 1 byte equal to 8 bits. So that means 2 bytes equal to 16 bits. So here, if you are no sign, so the value start from 0 to 2 to the 16 power. Okay, let me write it down. That's I write down here. Because you say, what I mean 0 to 65, 535. So that's how we calculate. Because we start from 0. Because you have 2 bytes, that means you have 16 bits. Each bit can be 0 or 1. So then the total value can be 2 to the 16 power minus 1. Because this one actually is because we start from 0. So that's how you will calculate according to your memory size is different. Then the range, how much you can save is different. If you are unsigned, that means no sign. So start from 0 or positive. Then if you have including the sign, so that's why you see because you can have positive number or negative number. So that's why the short int range will be kind of you see in the middle for that so many value. Okay, so that's between this value. So on the other hand, if you have 4 byte int, so then they have 32 bit can contain the value, but int they including positive and negative. So then you have unsigned integer. Unsigned integer also is 4 bytes, but you see here they will be bigger than your int because they don't have negative number. So then you have long int. The long int actually is the same as the int. The only thing you have even bigger int is this one. We have long int. So if we do the long int data type, they have 8 bytes for you. So that's why here you have so many different integer data type, right? But usually our value int for 4 bytes is good enough. You can see that's the 2 billion, positive or negative 2 billion. So unless you really have much bigger data you want to save, use the long int. Otherwise, usually we use the int. Okay, so that's why most of the time when you see we define the integer data type, we use the int. So you see we can have the int length width. But here if you want, because length and width should be positive, right? So if you want to make sure they are positive, then you can do unsigned. But one thing is be careful, like we say, variable with different data type, they need to be in different definition. So that means you have semicolon here. You have, for this one, you can write int, length, then comma, width, because they are the same data type. But for the unsigned int, you need to start another statement. So then you can see the example number 3. So we will show you, we define integer or unsigned integer or long integer. Okay, so they all have different thing. Okay, so you can try, because int we can be positive, negative. So then, but unsigned only can be positive. So then you can check if you accidentally make that become negative, what will happen? Okay. So yeah, whenever you define a variable, you need to assign a literal value. Okay, so here we just show you they have the integer. Sometimes the integer we have the long integer or long, but then you need to make sure when you add the data type at the end for your literal value, they need to match the data you define. Otherwise, the integer literal usually stored in the memory as int as default. That means 4 bytes. So in this video, we cover the numeric number. So sometimes your number can be integer. So that's why next one we'll talk about. If your number need to have decimal, then you cannot define int. So that's why here, we go back to this example. Let me go to example 3. I show you in our Cloud9. Okay, so that's in Cloud9. You see, that's our example 3. So let me go up so you can see the simple output. Okay, so then when we run, so you can display the checking, we will display -20. So miles is 4276. You see the output. You see, so the checking balance is -20. So that's the output. Okay, so let's try. So here, because our checking is integer, so we can have negative number. How about when we do the unsigned integer? If I accidentally assign my unsigned integer is negative, we see what happened. Okay, you see, even you give them the negative sign, but because you already defined that unsigned, they ignore the sign digit. Okay, so that's what I want to show you. You also can try. So then continue, we see earlier we say our checking is integer, right? So how about I give them decimal? So we see what happened. You see, even I give them with a decimal, but they only show the integer part. The reason is because I already defined this variable is integer. So that's why when we save in the memory, they only save the integer part. Even you assign me the decimal, but I have no room to save your digit. So they won't do rounding. They just ignore the decimal part. So that's why even you try to assign a decimal number to an integer variable, they only take your integer part. Okay, so if you are interested about that, actually this one is our chapter 2, example 3. Okay, so you can just run the program and see what happened. Yeah, so the next one we can talk about the floating point data. So if you really want to save the decimal number, you need to define another variable to save for that. So that's our floating data type. So actually your floating point data type, just like our int. Int, you have long int, short int, unsigned int. So our floating point, actually we have a couple different ways. You have float data type, you have double data type, or you have long data type. But each one, they all can save decimal. So when you save in the memory, okay, so later we will show you the memory size. So the memory size, they will store specific space for the integer part, specific space for the decimal part. So on the other hand, you see the whole number, even you have a floating point number, right? So floating point number, But when they try to save in memory, they kind of separate the whole number part and the decimal part. Okay, so then all the floating point actually they are signed. They don't have unsigned. So we can see here. Okay, so your float, double, or long double. So I'm not sure if this class someone asked me about the float and double. So one thing is what's different between float and a double or long double. You can see they just different between the memory size. Okay, so then they have the single precision, double precision, and long double precision. So when they say the precision, actually is how accurate your decimal can be. Just usually, even the float and double, they are similar. Float actually is the last byte. So then if you want, you can define float instead of double if your value is not that big. Okay, so sometimes when you display your floating number, they can be the fixed point. So that's why we have the keyword fixed. We will talk about in next couple of weeks. Or we have the scientific notation. So sometimes you will see they display like this, all the digits. Or you can see the E. Also the E means 3.14159 times 10 to the 1st power. So this one you see on 0.0000625, right? So they will change, become scientific notation. So that means 6.25 times 10 to the negative 5 power. So after you understand the floating point, so then we will see the example. So if you define float as distance, so that's 4 bytes in memory. If you define double, that means you have 8 bytes in memory. So when you write like this, you can see here is E. That means you have a number, decimal number is 1.495979 times 10 to the 11th power. So then you have your mass like this. So when you give them a scientific notation, you see they also display in scientific notation in your output. Yeah, of course, because like earlier we say the floating point is positive, negative. So you also can try you want to become negative. Or even the distance and mass, suppose they should be positive. So using the example 6, run on your program. Even I didn't show you here how they run. You should download this file and run on your IDE and test different values, see how the result is. So then after you finish this video, actually you will stop for our Monday. You are prepared for our Monday lecture already. So what we will do is, if you have questions, I will answer you during the Zoom meeting. So then you will ready for your lab exercise too.